Why don't you guys get out the circuit sheet?
I was in the
Do you want me to start by, did you guys run into any issues on some of the ones we marked down yesterday to do? Do you want me to try to go over some of those? Otherwise, yeah, because I'll gladly do that first, and then kind of get to the more complicated ones.
What number is that?
I don't remember.
Like, second column, fourth one down.
This one?
Yeah.
Did I tell you guys to do that one?
Yeah. That one was hard.
Okay. I was planning on doing that one today. But I'll do that one right away, sure.
Did you do one of the table ones?
Yes, I can do a table one. So, it sounds like I told you guys to do this one yesterday.
Yeah. I think so.
Okay, that one honestly could be kind of a 50-50. It's only more difficult because it's product rule. The chain rule part of this one isn't complicated. It's just the fact that it has multiple things going on. I'll definitely do a table one next. Come on. Okay, so the first thing I guess I would start with is I've got X squared plus 7 to the third power. And I'm generally always going to write any kind of root as a fraction power because then I can do power rule. So this is going to be like F, my first item. Cosine would be G. Because of lack of space, I'm not going to try to write F prime, G prime, but otherwise that would be a good plan. And I don't know if you guys even tried, but do know, I don't care if you write in this space or not, like, you can just do the problem on another sheet of paper at any point, because there's not much space here. And some of these are going to take up a bunch of space. So for product rule, I'm going to have the first item. Derivative of second, so far we haven't done anything with chain rule. Derivative of cosine would be negative sine, plus the second item, G, and then times the derivative of the first, which is where we're running a chain rule, because I've got a power on a group of things. So derivative of the outer is what I start with. So I'm going to pretend this is something to the third power. 1/3 something. I'm going to subtract 1 from the power, so negative 2/3. And then I need to multiply by the derivative of the inside. So 2x. Maybe I should start by asking that. Did you guys have trouble figuring out what was inside, outside? Because we certainly could do a lot more of that today, if that helps. Okay? I am okay with this as an answer. I know, because we're just starting, but I also know that on this circuit worksheet, I'm pretty positive that was not the answer that was listed.
On the test, would you make us simplify this?
So on the test, the question can be one of two things. One, if it's multiple choice, 100% it would be simplified as far as possible. If it is free response, frequently I will just ask you to write the first step of product rule. And so then that would be this before simplification, because I would just want to know if you could do the parts correctly. Now for simplification, what's going to happen is I've got first term, second term, and I'm going to look for common multipliers, which they both have the same parentheses x squared plus 7. So that's going to get factored out. So the circuit worksheet answer, this is where it's going to come from. So I'm going to take out x squared plus 7. Ooh, I almost forgot. I got my little spinner thing now ready. remember what power we factor out? I mean, I think not derivative. I think that's kind of what you're referring to. So if I have x squared plus x to the 8th, what power would I factor out of both of these? Okay, now we chose 2 because it was the smaller number. So on this one, I've got x squared plus 7 to the 3rd, x squared plus 7 to the negative 2/3. So what would I factor out for the power? The smaller of the two. And so smaller generally is just going to mean the most negative, I guess. Like if you think of one big number line, negative 2/3 would be smaller. 1/3 itself is a smaller number, but. So we're factoring out x squared plus 7 to the negative 2/3. Everything else, I have zero idea if it goes together or not. It's just gonna be a bunch of things left over. X squared plus 7. I was hoping somebody could tell me what power would be on x squared plus 7. Ryan, wait, oh, there you go. What power would I write on x squared plus 7 if I take out negative 2/3 power? 1/3 was the original power that was there, and I'm going to remove negative 2/3. Do you remember what we do with the powers? Okay, you're going to take the original power, subtract what you took out. So it would be 1/3 minus negative 2/3, which would be 1. Now, how should I phrase this? This is super common. It's almost always going to be to the first power, because when we do power rule, you subtract 1. And so the number that you always factor out is exactly 1 less than what you factor when you take out a common factor. So this is almost always going to be the first power just because of the way the power rule works. So take out x squared plus 7 to the first, and then I still have negative sine x in there, plus cosine x. And then I took out that entire parentheses. I still have 1/3 times 2x. I'm going to guess this is probably like the answer that's written down, but they would move that to the bottom. Say it again?
What did you do with the exponents? Because what I would do is subtract and get negative 1/3. That's probably the first thing.
So you subtract the power that you removed. We removed negative 2/3.
Oh, so.
Yes. So that's why it turns into a 1. And it's almost always going to be a 1 just because of the way it's set up. Did anybody find the answer on the answer key or on the sheet?
Yes.
Okay, is it written pretty much like this with the root on the bottom? Okay. There's a lot of different ways you can choose to write the final answer. So it's on multiple choice. That's one thing I dislike because you have to sit there and try to figure out which one your answer is equal to. Okay, should I go to a table one? Oh. No, that's not it, is it?
That's it.
Oh, yeah, x squared plus 7. That's odd that they multiplied out the x squared plus 7. Okay. Okay, table 1. It says let h equal f of g of x. This is pretty much the only part of this that runs into difficulty. Winston, when we have f of g of x, what's considered the inside and outside?
G of x is inside.
Perfect. G of x is considered the inside, f is the outside. So when we're doing the derivative of this, do the derivative of the outside. The derivative of the outside would be f prime. We don't change the parentheses. And then you multiply it by the derivative of the inside. So when it asks for h prime of 2, you pretty much just need to know this info. And obviously this table is going to have a boatload of extra things that you don't need. So f prime g of 2. G of 2 is negative 1. G prime of 2 would be 3. And then lastly, I'm going to find f prime of negative 1, which is negative 4/3. So negative 4 would be the answer. The table ones are 100%. You just kind of need to be able to read the notation. Finding the answers is super easy. It's always all about the notation. Okay, was there a different one that maybe you ran into trouble that you were trying that you were supposed to do yesterday?
Could I just have this sheet, please?
Oh, yeah, that's important too, huh?
Yeah.
Yes. I was going to say, I'm pretty sure I set it off to the side for you. I forgot to give it to you yesterday. Yes, so I told everybody to just flat out ignore the notes and the homework from section 1 in the packet.
Okay.
Did the ones you tried went okay then? Okay, if they did, that's fantastic. If you didn't have a chance to try it yet, I understand, but you'll do know that in Schoology, I put that we would try to have this worksheet done by tomorrow night. Does that sound fair enough for time-wise?
Yes.
Okay, I didn't think it would take terribly long, especially since we're doing it in class, but, I mean, I'm not trying to monopolize your time either. I know you guys have classes that absolutely do monopolize your time. You know what, let's just do this one right now, I guess. Let's just move to the harder type. Oh, shoot, I need a separate tablet so I can do the spinner separate. Luke. The part about this question that most people get wrong, if they do, what does that squared mean?
It means that the result of tangent 3x squared is.
Okay, so the entire thing is being squared.
Right.
Okay, so the reason most people will do this incorrectly is they kind of feel like the squared is just on tangent, which it is, but in most people's minds that doesn't mean the angle. So you probably want to rewrite this. You probably want to rewrite the problem as this. If you rewrite it as that, then we have kind of a clear inside-outside. Uh-oh. Liv. What's inside outside?
Inside is 3x squared and, or inside is tan of 3x
There you
squared
go.
and outside is squared.
Yes. So 3x squared will also be a separate inside, but not yet. So what we're doing right now, what we're going to start with is this is the inside, this is the outside. And when we need more detail, we will. So, derivative of the outside, derivative of the squared. 2 times this item, we don't even care what's inside of it, we just rewrite the entire thing, to the first. And then we need to multiply by the derivative of the inside. As soon as you get to the stage where we're gonna take the derivative of the inside, what I traditionally try to do is I 100% ignore, see if I can do this nicely. I ignore everything I did on the outside. So this tangent of 3x squared is like a whole new problem. This is how you do. You guys ever seen the movie Inception? It's kind of old now, I suppose. So, the whole idea of that movie, there was a dream within a dream. This is a chain rule within a chain rule. And they get very confusing if you try to look at it as a whole. So you should try to only look at parts at a time if you can. So when I get to the stage where I'm going to do derivative of the inside, I absolutely ignore everything I did before because now I'm focused on just the inside. And I no longer think of it as the inside. It's just an entirely new problem. And the reason that matters is the derivative of tangent of 3x squared, this is now the inside, tangent is now the outside. And so if I'm going to do the derivative, tangent of 3x squared, I do the derivative of the outside, which is secant squared of the angle, I don't ever change the angle, times the derivative of the inside, which would be 6x. Now, it is technically possible that the inside of the angle could have its own chain rule, but I don't recall ever seeing a triple chain rule on the AP test. So these are traditionally the types of problems that will confuse you because they have multiple steps, multiple chain rules.
So on the test, when we get like a triple chain, just a double.
Definitely, I'm not gonna say that. I said on the AP test, I don't remember them ever giving you a triple chain rule. What are you doing?
Just play games.
It looks like you're doing cookie clicker. I know you're not. I pray you're not. But it looks like you're doing cookie clicker. Okay, you guys want me to try to make up another problem like this for you to try? I realize it's not on the sheet. I don't care where you write it. But it might be a good idea just to try a double chain rule one. Should we go triple chain rule? Not yet, alright. Alright, my bad. Okay, we won't do triple chain rule yet. Try to find the derivative of that. I mean, it's not easy, that's for sure, but I made the parts semi-straightforward. Cold's going that good, huh? I said your cold is going that good, huh? Oh, yeah, I got lots of cleaning. That is why I stock up on Kleenex and hand sanitizer.
If the inside in the bracket that is LNOX,
Yep.
will this technically then be triple-shade away since that the derivative of LNOX is one of the x?
No, that is the double shield. So the cosecant on the inside is the first chain rule. The ln of x on the inside of cosecant is the second chain rule.
Is it negative cosecant?
I don't get those.
Alright.
Yeah, that, I mean, the only thing that possibly simplifies the negative going into that. But yes, that's. Yeah, you could move that too. What'd you say? Oh, okay. It's a J or a Thea?
Probably J, probably J.
It was J.
No, LNOX is J.
Oh, that's right, he's gone.
Derivative of LNOX.
No wonder why you were rooting for him so hard.
Probably J.
Abby. I was hoping you could tell me what is the inside and what is the outside. Theoretically, the inside is literally the inside, so it's like it feels like I'm trying to trick you, but what is physically on the outside? Root symbol, okay? So the root is the outside. The inside, everything written on the inside. So if there's ever a parentheses, the inside is traditionally whatever is inside the parentheses. Outside is whatever's outside of that. Like it generally is going to actually follow inside outside. So we want to rewrite this because we don't want to use a root symbol. If some of you just rewrite it in your head, that's fine. You don't have to physically rewrite it to be correct. But I'll rewrite it for our problem. So we've got cosecant of ln of x on the inside, 1/2 power on the outside, which was the root symbol. So derivative of the outside, 1/2 whatever to the negative half. I mean, I would just rewrite that. Like, I don't even worry about what's on the inside until I get to derivative of the inside. And then at the end, derivative of the inside. So now I'm gonna do whole complete separate problem where I ignore the parentheses and the 1/2 power, and cosecant of ln of x is my new problem. The derivative of cosecant of ln of x, well, I now have an inside and an outside again. So derivative of outside, derivative of cosecant is negative cosecant cotan, shoot, I ran out of space, times the derivative of the inside, which would be the derivative of ln of x. Now, this sort of simplifies. Because this cosecant is within a power, I can't put it with those out there. So this would have to stay separate as a root on the bottom. I could theoretically put these two together as a first power and a negative half power, so if you want, you can. I made this one up so it's not like we have an answer to look at. But the half, the negative, and the 1 over x are kind of on their own, so we can put them together and say 1 over, negative 1 over 2x. And then however you want to put together the trig things, it's kind of your choice. I personally don't want to combine them together, it feels more confusing, so I would probably put cosecant, cotan on the top. Negative power on the bottom. The answers you're gonna get are gonna look terrible. It doesn't matter how bad your answers look, because generally what we're doing with them is putting numbers in place of x. Technically, we could try to find zeros or something, but that's a whole separate issue.
So when I was doing this problem, I did it, like I thought about it, started taking, I got the same answer though. I did, well, first one, we get 1/2 of cosecant on of x, and try to negative 1/2. But then, cause like the inside of the first one is cosecant 1 of x, I did like the u times u prime, like that rule.
Oh, that is,
They
the
end up
u
being
times
the
u
same.
prime is inside outside.
Yeah, cause like if I was writing it up there, I would have written like the derivative of cosecant 1 of x in blue, and then the last part.
Oh, sure.
Is the same.
Yeah, it's not wrong, yep. That is the same thing, just different perspective. I don't know, scale 0 to 5, how are we feeling about double chain rule? Not that I would expect you to be good at them yet, like, okay? Okay? The next thing we're gonna go over is actually easy, but you haven't seen the notation, so I thought it would be confusing. It was the second question on the right there. I don't know the numbers, just second box. Liliana. What about this problem was different than the ones you've had before, the reason I told you not to do it?
There's 2 primes.
2 primes, correct, that's perfect. We haven't run into this, and I don't remember if it's section 3 or 4 or 5. It's called a second derivative. It's no more difficult than anything else. So if you see 2 quotes, 2 apostrophes, that's just telling you how many times you're supposed to take the derivative. You can technically have 3 apostrophes, and then if they go past 3, they just put a number instead of tick marks. So second derivative, I have to do the first derivative first. So first derivative is just what we call the normal derivative. The main place you're gonna use second derivative is physics. And some of you in physics might have already run into it. Position, velocity, and acceleration are all derivatives. So if you have a position function, the derivative of position is velocity. The derivative of velocity is acceleration. And that's how they came up with the formulas, to be honest. The second half of calc, I'll show you guys how they just took, what's the story? The story is like Newton measured the apple, how long it took to fall, right? For acceleration, is that correct? Didn't you guys talk about acceleration yet?
Not how it was initially.
Don't you guys have to measure it?
Yeah, we
just on a computer? That's not the same thing at all. Okay, basically, the story was that Newton watched an apple fall and saw that it was falling faster at the bottom than the top. So he recorded how much faster it fell along the way, and so that was called the acceleration. So he measured acceleration. And then from the acceleration, you're able to figure out velocity equation using integration that we haven't learned yet. From that, figure out position. That's why those formulas that you're given are so ridiculously complicated. Acceleration formula is simple and easy. Velocity is a little bit worse. Position, whole lot of different things. That's how come. So, that was the quick story of derivatives. Derivative of the sine of x squared, derivative of the outside would be cosine times the derivative of the inside, which is 2x. Now, here's where it gets worse. Second derivative is the derivative of the first derivative. This is only worse because we have two separate items, and so we have to use product rule. The derivative is no harder, it's just the fact that what we're given is harder. So I have to do product rule on this. So first, just rewrite the first thing, times the derivative of the second. 2 plus the second item times the derivative of the first, which I'm basically going to do the exact same chain rule I did from the first problem, but it's got cosine instead of sine. So derivative of the outside times derivative of the inside. And that can be simplified however you want. I have no idea how they simplified it on the worksheet, but I imagine they factored out the 2 possibly, otherwise they would have just left it. Like, they could have multiplied 2x and 2x. They don't really have anything in common, so. They probably wrote 2 cosine x squared minus 4x squared sine of x squared. They always like to write positive things first, negative things later if they can. Okay. I don't actually think there's anything more difficult on this sheet. I think it's just mainly all about practicing when to use chain rule, because that's where, when everything's mixed together, some people have trouble figuring out when to use chain rule. So that's kind of what I want you to practice. So we have not 20 minutes, but close. I thought you would be able to get a handful done from this worksheet, and it's entirely possible some of you are just going to be done with the worksheet before you leave here today, so you could have your whole first homework done already.
I have a question for Josh, and then I already got on the second page.
Bottom right on the second page.
Yeah, I still don't know what dy over dx is, it just the normal derivative or?
Oh, thanks, I didn't even notice that. Correct. dy dx is how they say derivative if you have y. dy dx is the same thing as y prime. Okay, I will gladly just help anybody with any problems for this 20 minutes. I know we didn't have an entire work day. If this was non-AP Calc, I would definitely spend like at least 2-3 more days on this topic, because it's a lot of information to just practice and get down well before we move on, but we don't have that time. So I'll try to give you as much work time as I can. And I know some of you are very good about coming before school, after school, or R&R. Like I said before, if you ever come in R&R, even if it's listed as full, I can imagine. Half those kids usually just all sit together in the old corner anyway, so. Okay,